Hi guys, welcome to this new video. On this opportunity, we want to solve the part B of this problem. We already solved the part A on the last video. The problem says that we have a uniform spherical ball of mass m rolling without slipping down a wedge of mass m and angle alpha, which itself can slide without friction on an horizontal table. The system moves in the plane shown in the figure, and G denotes the gravitational acceleration. We already found the Lagrangian and the equation of motion for this system on the last problem, and for this time we want to do the second part, and the second part is for the special case when the mass of the wedge is equal to the mass of the ball and the angle alpha is equal to p quarters. We want to find the acceleration of the wedge and the acceleration of the ball relative to the wedge. Okay guys, from the last video we already know the Lagrange equations of motion for this system. These are the equations. As we know, we calculated these equations on the last video, and we call these equations equation number 1 and number 2. And from equation number 2, we want to solve for y2 dots, right? We want to solve for y2 dots. We take the second and third term of the equation, the second term. The third term, we send them to the other side of the equation, and we get 7/5 of the mass y2 dots minus, okay, equal to mg sine of alpha. It was negative, and we send it to the other side as a positive, minus 7/5 of the mass x2 dots cosine of alpha. It was positive, and we send it to the other side of the equation as negative, right? Okay, now we take the 7m, it's multiplying right here. We will send it to the other side of the equation dividing, okay? And the phi that is dividing, we send it to the other side of the equation multiplying, okay? And we finally get that y2 dots is equal to this. What we do now is we distribute this phi multiplying every time into the parentheses, and we get the following. And now we can simplify this phi with this phi, right? And finally we get the equation like this. Okay guys, let's call this equation equation number 3. What we are gonna do right now is we are gonna replace equation number 3 into equation number 1, okay? So we replace this equation number 3 into equation number 1. We have equation number 1 right here, so we are gonna take that equation number 3 and we will replace it right here on the y2 dots. So replacing equation number 3 into equation number 1, we get 7/5 mass x2 dots plus 7/5 mass. Okay, we know that we have to replace y2 dots, and y2 dots is equation number 3. Phi m g sine of alpha minus 7m x2 dots cosine of alpha dividing 7m, okay, cosine of alpha plus, okay, mass of the wedge plus mass of the ball x2 dots, and this is equal to 0. Okay, okay, we can, here we can, this 7 with this 7 we can simplify it. We can simplify this m with the m in the denominator. All right, we can now take this phi and we'll send it right to the denominator. We have 7/5 of the mass x2 dots. Okay, we have here like 1. So this is like having 1 dividing phi, right? This is like 1 dividing phi that we have here. And we send 1/5 into the parentheses, and we get phi m g sine of theta, sine of alpha, sorry. Okay, we have to multiply this cosine of alpha, okay? This cosine of alpha is gonna multiply here and here, okay? And we have cosine of alpha minus 7/5 of the mass x2 dots cosine square of alpha plus mm s2 dots equal to 0. Okay, some terms are simplifying. We can, okay, because we are gonna do something. We are gonna divide all the equation by the mass, okay, by the mass of the ball. I'm gonna divide each term of the equation by the mass of the ball. So it's like dividing by the mass of the ball here, and for each term I do the same, okay? And when I do that, I get, okay, besides that, I will gonna get this term of the equation that is adding on this part of the equation, and I will send it to the other side of the equation, and it's gonna be subtracting, obviously, okay? When I do that, I will get the following part, or the following equation. Okay, what I did this is, like I said, I'm sending the ng sine of alpha cosine of alpha to the other side of the equation, dividing each term by the mass of the ball. Okay, I forgot to do this, but obviously the masses are simplifying each other, right? And now we can see something here. On each term on the left side of the equation, I have the x2 dots, and x2 dots. What I'm doing right now is factoring these x2 dots. I'm taking common factor out x2 dots of this equation, okay? And when I do that, I get the following. Okay, this is the equation that we got. Now we take the part that is multiplying the x2 dots and send it to divide to the other side of the equation. Now we take in this part, we take 7/5 factor common out, right? And the result is this. We know that 1 minus cosine square of alpha is sine of square of alpha. Okay? Then the equation is going to look like this. Okay? The next step is taking out common factor 1 over 5m out of this equation, out of the last equation. Okay? From the denominator, we are taking that common factor out. Then we will have the following equation. Okay? This is what I got. The final step would be, we know the denominator of the denominator go to the numerator. Okay? The denominator of the denominator goes to the numerator. And I distribute this 5 multiplying each term inside the parentheses. And finally, this is the result. Okay? This is the acceleration of the wedge. Okay, guys? The acceleration of the wedge. This acceleration, as you can see, is negative because the wedge is moving to the left according to the problem. Let's call this equation number 4. Now we are going to take this equation and we are going to replace it into equation number 2. Okay, we remember that equation number 2 is this, and we are taking equation number 4, and we are replacing that equation number 4 into this part of equation number 2, and we will get the following. I will simplify this 5 with this 5. The mass of the ball is on each term of the equation, so we can simplify it as well. I will do a little trick in the denominator of this part. I will take common factor m out of these two terms, and the equation is going to look like this. The next step is to multiply every term of the equation times 5/7. Then I cancel 5, 5, 7, 7, 7, 7 as well. Next, I send this part of the equation. I cleared y2 dots. I leave y2 dots by itself, sending this second term to the other side of the equation. The second term is subtracting. I will send it adding, and the same for the third term. Subtracting, I will send it to the other side of the equation, and it's going to be adding. Finally, y2 dots is taking form like this: pi mg sine of alpha. Okay, we know cosine, multiplying this cosine is cosine square of alpha, right? Multiplying this cosine. This is dividing phi m plus phi plus 7 sine squared of alpha, mass of the ball, plus 5 dividing 7 g sine of alpha. The idea is to simplify this term. This equation is, the idea is taking this term in a simplest way, the simplest way as possible we can. So we are going to do some algebra here to reduce this equation to the minimum expression, okay? I will do this operation. I have here a fraction on this part. I have this fraction, and I will do the operation that is done when we are adding fractions, right? So as we know, it's algebra. It's taking this, multiplying numerator times denominator, this denominator times the numerator, and after we do the denominators, okay? We all know that. We already know that. So let's go to the next page and do that operation. And it's going to be something like y2 dots is equal to, okay, what I did here is I multiplied in cross the terms of the fraction, right? Crossing, multiplying, and I get this. Sine square of alpha plus 35 mg sine of alpha cosine square of alpha. Okay guys, I know this is a little bit exhausting, a little bit long, but we are getting it. We are getting it. This is 7 phi m plus 5 plus 7 sine square of alpha m. Okay. Okay, the next part of this is I will take this phi g sine of alpha as a common factor on the numerator of this equation. Okay, I take this phi g out as a common factor, so it's going to be phi g sine of alpha. Okay, this is multiplying, it was multiplying this phi m plus 5 plus 7 sine square of alpha m. Okay, because I took common factor out phi, the result here is going to be 7 m cosine square of alpha. Okay, all this is multiplying the same 7 phi m plus 5 plus 7 sine square of alpha m. I'm gonna distribute everything on the numerator. I'm gonna distribute this. I will write this, okay, this phi multiplying this m, 7 sine square of alpha is multiplying this m as well, okay, and I will distribute those terms on the numerator of this equation, and the final result is this. Okay, now I will take common factor out on this part of the equation. I get 7m sine square of alpha and 7m cosine square of alpha. So I take common factor out 7m. And we already know that, okay, we know that that is 1, right? That's equal to 1. Sine squared of alpha plus cosine squared of alpha is equal to 1. And because this is equal to 1, after I will do the 5m plus 7m, and that is going to be equal to 12m. And finally, the equation for the acceleration of the ball relative to the wedge is the following. y2 dots equal to 5g sine of alpha 5m mass of this is the mass of the wedge, okay, we know that already, plus the mass of the ball dividing 7 5m plus 5 plus 7 sine square of alpha m. And this is the, let's call this equation number 5, and this is the acceleration of the ball relative to the wedge. Now we have the special cases, okay? We want to find the acceleration of the wedge and the acceleration of the ball for the following specification. For the special cases when we have when the mass of the wedge is equal to the mass of the ball, and when the angle alpha is equal to p quarters, okay? Those are the conditions that we have, and we want to find the acceleration of the wedge and the acceleration of the ball relative with the wedge under those conditions. We already know that we will use these trigonometric expressions, okay? We already know that sine of p quarters is equal to right square of 2 dividing 2. Okay, we know that cosine of p quarters is equal to right square of 2 dividing 2. Okay, sine square of p quarters is equal to 1/2. The same for the cosine square of p quarters is equal to 1/2. So we need those expressions that we already know to use them when we want to find the acceleration for the ball and the wedge under those conditions. Let's go first to the equation number 4. We know that equation number 4 is the following equation. We already calculated this equation. The only thing I will do here is write it. The only thing I will do here is to replace, mass of the ball equal to the mass of the wedge, and the angle alpha equal to p quarters. Then when we do that, we have 5m g, okay, sine of alpha is raised square of 2 dividing 2, cosine of alpha raised root square of 2 dividing 2, dividing 5m plus 7m, we know mass of the ball now is equal to the mass of the wedge. Okay, sine of alpha is root square of 2 dividing 2 plus 5m. It's easy to see that we can, the mass, we can simplify it real fast because it's on each term of the equation, on the numerator and the denominator as well. This is going to be something like minus 5, okay, 5g, okay, We have here root square of 2 dividing 2 multiplying root square of 2 multiplying 2 dividing 2, sorry, and that is equal to 2 dividing 4. Okay, here we have 5 plus 5 is 10, okay, plus 7 root square of 2 dividing 2. I have to remember here that this is a square, sine of square, okay? Then this is a square, and this is a square, okay? Okay, let's do something here real fast. I get x2 dots equal to minus 5g, okay? This is 1/2, okay? This is 10 plus 7 multiplying 1/2, and this is equal to minus 5g dividing 2 dividing 10 plus 7 half. Okay, let's do this denominator, and we will have x2 dots equal to minus 5g dividing 2. Okay, this is 10 plus, this is 20. Okay, let's do something. I think that I don't have enough room here, so I will go to this part. 5g dividing 2 minus, okay, this is 20, right? Because I have to multiply this, right? Plus 7 dividing 2. Okay, because this is in the denominator of the numerator and this is on the denominator of the denominator, I can simplify it. All right, then x2 dots is equal to the minus 5g dividing 27, and this is the acceleration of the wedge under the conditions when the mass of the wedge are equal and when alpha is equal to p quarters. And this is the acceleration of the wedge under the conditions that the problem is giving to us, guys. Next, let's calculate the acceleration of the ball relative to the wedge under the conditions that we have. We know that the acceleration of the ball is the following equation. We already know the equation. I just gonna write it down real fast. That's the equation, right? And okay, we have the conditions. M equal m and alpha equal p quarters. We have those conditions. Okay, let's replace those conditions into this equation. Then we get y2 dots is equal to 5g sine of alpha plus 5m plus 12m, okay, dividing 7 5m plus 5 plus 7. Okay, sine square of p quarters is 1/2 m. Okay guys, I forgot here, sorry. Here is root square of 2 dividing 2. Okay. All right, then we have this is equal to y2 dots is equal to, okay, 5g root square of 2 dividing 2, okay, 17m dividing 7, here is 5m, okay, plus, okay, we have here, this is inside the parentheses is 5, okay, we do the fraction is 10 plus 7 dividing 2, okay, multiplying the mass. We can simplify the masses because the mass is on each term of the equation. We can simplify the masses, and this is gonna be equal to 5g, okay, 5 times g, sorry, 5 times 17 is equal to 85, okay, is equal to 85, so this is 85 g root square of 2 dividing 2, okay, all this is dividing 7, and this 7 is multiplying 5 plus, okay, this is 17 half, all right, then this is equal to, let's do this part inside the parentheses, that part is equal to 17 halves, right, is equal to 17 half, this part, and I can simplify these two with these two. I mean, it's 1/2 on the numerator and 1/2 on the denominator, and 7 times 17 is equal to 189. And finally, the expression for the acceleration of the ball relative to the wedge under the conditions given by the problem is 85 root square of 2 dividing 189 g. Okay guys, this is the acceleration of the ball when the conditions are the mass of the ball is equal to the mass of the wedge and alpha is equal to p quarters. This is the acceleration of the ball relative to the wedge. Okay guys, thank you for watching. Please give me a thumb up, subscribe to my channel if you like it. If you want to comment something about the problem, if you see something in the problem, you are free to comment and let me know. Please subscribe it. Thank you for watching and see you on the next video. Bye.